Hi everyone, this is Rongyue, and this video is for homework 6, question 1. Okay, now let's take a look at this question. The first question asks to find A. To make this is a valid joint density function. We could calculate this integral of this density function and let it equal 1, which is it's very easy to calculate. It is equal to 4 over A, and let it equal 1. So we could get A is equal to 4. The second question asks that to check if X and Y are uncorrelated. We could calculate the expected value of X times Y, which is we could use the density function, and it's very easy to calculate too. The expected value of x, y is 1 over 9. And the expected value of x is also easy to calculate. And this is equal to 0. Since Ex is equal to 0, we don't need to calculate Ey. We could just get the information that Exy is not equal to Ex times Ey, because Ex is 0 and Exy is not 0. So X and Y are not uncorrelated. And for the third question, since they are not uncorrelated and they are jointly normal, they are not independent too. We could get this from question 2, right? And for the fourth question, it asks us to find the joint density function of x squared and y squared. We could assume that z equals x squared and w equals y squared. And its Jacobian is this is 2x 0 to y. So for this equation says it has 4 roots, right? And this is when z is between 0 and 1, w is between 0 and 1. The absolute value of gi is equal to 4 times square root of z times the square root of w. Right? And I is equal to 1, 2, 3, 4. And its density function fzw is equal to fxy over absolute value of G1. Plus fxy minus square root of z minus square root of w over g for absolute value. Right? And this is equal to one over 4 times square root of z times square root of w times 1 over 4. And the answer is this. This is when z and w is between 0 and 1. So when otherwise fzw is equal to 0. So we could write its function, this function as this is when d is between 0 and 1 and w is between 0 and 1. Otherwise, the value is 0. And it's very easy to say this is also equal to fz times fw. Right? And we could also write the density function of z and w. Fz is equal to 1 over 2 times the square root of z when z is between 0 and 1. Otherwise, it's 0. Also, fw is equal to 1 over 2 times square root of w when w is between 0 and 1. Otherwise, it's 0. And we could say that also for the fifth question, x squared, which is z, y squared, which is w, are independent. That's all. Thank you.